Hello everyone, in this video we are going to discuss about active filter types. So here we have total 5 types of active filter. So low pass filter, high pass filter, band pass filter and band stop filter and all pass filter. So we'll discuss each and every filter briefly. So first of all we have low pass filter. So low pass filter, what it will do? So low pass filter will passes all the low frequency bandwidth. So it is passing all the low frequency bandwidth and stopping the high frequency bandwidth. So here we can say that from 0 to FH it is passes. After FH it is going to stop. And high pass filter, what it is doing? From 0 to FL, that is till this point it is going to block all the frequency, that is we are going to stop that frequency length, and after FL, that is cutoff frequency, we are going to pass whatever present in the high level, we are going to pass that frequency length. And in band pass filter, what we are going to do? We are going to take the maximum level of the frequency which we are going to pass, and other minimum level we are going to stop the frequency. So the maximum level bandwidth we will be going to pass. And next, bandwidth rejection. So it will take all the maximum level filter and rejects whichever is in the fully low level filter. We'll see how the classification is done in low pass filter. So low pass filter is a classification of first order active low pass filter and second order low pass filter. What we are doing? So in low pass filter we have single resistor and single capacitor which is used for creating our circuit, that we called is first order. So single resistor, single capacitor is nothing but our first order. So we are getting single resistor and single capacitor connected to the input level, and the voltage follower is given at the inverting terminal. So what we get, the voltage output is equals to input multiplied of 1 plus voltage follower RF divided by R1 we are getting. And what is the cutoff frequency? The cutoff frequency is given by 1 by 2 pi of RC. We are going to get 1 by 2 pi of RC. Next we have second order low pass filter. So second order low pass filter, what it is? We know that first order can be converted into the second order. Similar circuit we can convert into second order by applying the extra resistor and extra capacitor. We know that in second order we will apply one more resistor and one more capacitor. The frequency response of second order low pass Butterworth filter is identical to the first order low pass filter to stop the bandwidth of 40 decade. So after 40 decade the frequency will stop. As we have added an extra resistor and extra capacitor to the V in input, so to the V input, what is our frequency cutoff? It is 1 by 2 pi root of, why root of? Because we are applying extra capacitor, extra resistors, root of R2 into R3, C2 into C3. And next we have high pass Butterworth filter. High pass Butterworth filter passes the frequency of higher order which will pass the signal below the cutoff frequency. So here also we have first order high pass Butterworth filter. So here we know that it will reject all the low pass level filter and it will passes all the higher level filter. So in first order high pass filter, the first order is formed of similar circuit to the low pass filter, just interchanging the components of RC. So this circuit consists of passive filter followed by non-inverting amplifier. So we can say that it is having similar to the low pass filter. What we are doing, we are interchanging the resistor and capacitor places. So we are giving input to the capacitor and we are placing the resistor. So capacitor should not allow low frequency. So it acts as an open circuit and blocks the signal at the input. So the output is 0. So frequency length equals to 1 divided by 2 pi RC. It is similar to our first order low pass bandwidth, and AF, that is operational gain, is equals to 1 plus RF divided by R1. So next we have second order high pass filter. So we can say the first order high pass active filter is converted into second order high pass filter by adding extra RC. Similar to low pass, we are in second order we are adding extra RC, that is extra resistor and extra capacitor we are adding to the similar circuit of the first order high pass filter. So what we are getting? We are getting similar cutoff frequency, that is 1 divided by 2 pi of root of R2 into R3 into C2 into C3. Find the voltage gain which is using the, so we are getting V0 mod of divided by V input equals to operational gain root of our FL. FL is nothing but our bandwidth we are getting at a low frequency, and F whole to the power of 4. Next we have band pass filter. A band pass filter can be characterized by quality factor Q. Based on the quality factor, we are going to divide the band pass filter. So wide band pass filter and narrow band pass filter we have. So quality factor should be less than 10 in wide band, and in narrow band the quality factor should be greater than 10. So wide band pass filter, when a quality factor is less than 10, we are saying it as a wide band. First signal will be passed through the high pass filter. The output of the signal of this high pass filter will tends to be infinite. The signal which tends to infinite is given to the low pass filter at the end. So we are stopping the whatever present in the low frequency, and after high frequency we are going to stop, and whatever coming in between that we are telling that we are going to pass the band. So here the cutoff frequency is nothing but root of FH into FL. So we can say Q, that is quality factor, is equal to cutoff frequency by bandwidth. What is our bandwidth? FH minus FL. So the combination and cascading of first order low pass filter and high pass filter gives us a order of the band pass filter. Due to cascading, it gives the low level quality factor. The gain rolls at the both stop at plus or minus 20 decade. So here we have a circuit for wideband circuit. What we are doing? We are cascading the low pass filter first order and high pass first order circuit together. So we are getting it as 1 by 2 pi of root RC, because we are connecting the two first order high pass and low pass filter. So root of RC. So FC is nothing but root of FH into FL. FC is divided by bandwidth, that is FH minus FL. Next we have narrow band pass filter. A narrow band pass filter, a high Q filter will quality factor will give us the narrow pass bandwidth, that is quality factor is greater than 10. It has sharp bell type response and bandwidth which is very less. It is using only one active filter component. This is an inverting configuration. So here what we are doing, we are converting a single op-amp, and we are giving our input in the inverting terminal, which is having the parallel connection of capacitor and parallel connection of resistor, which will give us a sharp frequency bell type output. So we can say it is rejecting all the low frequency, and after high frequency it is rejecting all the frequency bandwidth. So cutoff frequency is nothing but 2 pi of root of R1 R2 into C1 C2. So quality factor is nothing but our cutoff frequency divided by bandwidth. We get 1 by 2 root of R2 divided by R1. So next we have band stop filter, which is also having wide band reject filter and a narrow band reject filter. So connecting low pass filter and high pass filter produces another kind of RC filter network called as a band stop filter. So when we are connecting together, that is high pass filter and a low pass filter, we are going to get a another band stop filter called as amplifier summing of low pass and high pass. So these both are first order low pass and first order high pass we will get our wideband rejection circuit. So it will reject all the low level frequencies. So here we can say the cutoff frequency of FL is 1 by 2 pi into RL into C, and FH is nothing but 1 by 2 pi RH of C, which is giving us the frequency at root of frequency at low into frequency at high. So the quality factor is equals to cutoff frequency by bandwidth. So the notch filters are highly selective high Q from band stop filter. The most common notch filter is designed using the T-notch filter network. So here we can say that when the input is applied, we are connecting 3 parallel resistor and 3 parallel capacitor, which is giving us the frequency cutoff, that is 1 by 4 into pi raised to R3 into C3. So which is giving us the sharp level of filters.